So we're talking about in this section geometric series 11.4. A geometric series is the sum of all the terms of a geometric sequence. So it's a sum again. We're adding a bunch of terms. A geometric sequence, here's 1, 3, 9, 27, 81, etc. So the R value from 1 to 3, 3 to 9, you're multiplying by 3. A geometric series is what we're talking about today. Now we're adding all those terms of a geometric sequence. And I want to show you where the formula comes from, so maybe you can remember the formula a little better if you know where it comes from. So let's say we have this same series, 1, 3, 9, 27, adding all those. And if we multiply both sides by 3, 3 is our R value. If we multiply by 3, we would have S times 3 is 3S, 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, etc. Until we get to the last term, 2187 times 3 is 6561. And then if we use that idea that our old friend from the 1800s, Carl Gauss, that he used, it's kind of the same idea. We subtract these two series. We would get 1s minus 3s is negative 2s sub 8. And all these subtract out, and we have 1, and we have 0 here, minus this would be negative 65, 61. And then we can find the sum of these 8 terms. So the sum of the 8 terms is 1 minus 65, 61, divided by negative 2. And you can probably do that in your head. This is negative 65, 60, divided by 2. So half of 65, 60 would be the answer of the sum, which would be faster, I guess, than actually trying to add all these up, unless you had a calculator. But the reason why I'm showing you this is to show you that this formula you could write as the sum of n terms is a 1, which is our first term, a sub 1, minus, to get this number, 65, 61, to get this number, we took our last term and we multiplied by r. R was the 3 that we were multiplied by, r. So we'd have a sub n times r. And we divided by negative 2, which came from this, which is 1 minus our r value. 3 was r. So 1 minus r. And this formula is what I have written right here. So I'm trying to demonstrate where this formula comes from by using these particular numbers. So this formula is one formula, the first term minus the last times r, divided by 1 minus r. And here's another formula, a sub 1 times 1 minus r to the n, divided by 1 minus r. This one is more common, the first one. We'll use a lot more today. But the second one's really handy for you to know as well. So I want you to know these two formulas in addition to the other 4 that you should know. So if you take your calculators out, we'll find these sums, the sum of n terms. So for the first one, oh, sorry, I forgot to mention one thing. When do you use which formula? Might be nice to know. Well, notice in this one, there's an n. In this one, there's an a sub n. So if you know n, you're told n, you can use the first formula. If you know a sub n, you use the second formula. And both of them you should be given r and a sub 1. So for the first example we have, notice we're given the last term, a sub 8. So we'll use the second formula, the last term, a sub 8. So the sum of 8 terms equals 3 minus 384 times 2 divided by 1 minus 2. And see if you could type that correctly into your calculator. That's a pretty easy one. They'll get more difficult as we go along. So you get positive 765. How about you try the next one? Notice you're given the last term again, so you'll be using the same formula. See if you can do that and get the right answer in your calculator. The answer is 300. Be really careful to use parentheses in the denominator, and be careful about all the negatives. So this was 300. On the next example, notice we're given n So we're going to be using this first formula that has an n right here. So it would look like this. You have s sub 7 equals 80 times, parentheses, 1 minus negative a half to the 7th divided by 1 minus negative a half. And see if you can type that correctly into your calculator. Be careful about distributing. I would recommend not distributing the negative because of the exponent. If the exponent's odd or even, you could get a different sign if you try to distribute the negative. So be careful about that. So the answer is 53.75. Do the numerator, and you get 80, that, blah, blah, blah. And then divide by 1.5. And see if you can do the next one. You use the same formula. Be careful about negatives. So the answer is negative 340. Be careful about the negatives. So the 4 examples we've done so far, you were given out front, you were just told, here's the first term, here's R, here's N. On an example like this, you have to discern what all the important information is. So if we're going to use the more common formula, the one we were just using, we would have a sub 1 is the first term, which is 7. We need R and we need N. But we're told that we're going to 10 terms, so that would be our N is 10. And then the R, we actually have to look at the numbers and see what you're multiplying by, which would be 3. 7 to 21, 21 to 63 is multiplied by 3. So you have sum of 10 numbers. And see if you could plug the numbers in correctly. So the answer is 2006, 668. And we'll move on. Sigma notation. We did sigma notation in section 2 to find a geometric series with sigma notation, such as this one. I have a 10 here. It won't always be a 10 at the top. But notice you have a particular form. If you have an exponent, that's an n minus 1 exponent, that tells you that it's geometric. If I give you a sigma notation that doesn't have an exponent, that looks something like, I don't know, a plus bx or something like that, or bn or whatever, then this would be arithmetic. Arithmetic. So you have to be able to tell the difference, what formula to use. And it's actually pretty easy. A sub 1 is what you get when you plug the bottom number into up here, which would be a b to the 0. A times b to the 0 is a times 1. So your first term is a. If you're in this format, that you start at 1, you have n minus 1, your first term is a. The number of terms you can count from 1 to 10, which is how many terms from 1 to 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're 10. In this case, n is 10. And the R value would be b. So it's actually pretty easy to glean the important information from sigma notation. Easier than arithmetic sigma notation. So with this first example, you have a sub 1 is 2. Your R value is negative 3. It's the one that's the base with the exponent. And n is from 1 to 6 is 6 terms. So you'd have the sum of 6 terms equals 2 times 1 minus negative 3 to the 6th divided by 1 minus negative 3, which is 4. 1 plus 3 is 4. And type that in our calculator, and we get this. Negative 364. See if you could do the next 2 examples. So on the second question, or the third question, here's the setup, and then we will say it's 4,000. We'll round 39999.99 to 4,000. And the middle question, here's the setup right here, and I will not tell you what it equals because one of my students, as I'm recording this video, one of my students is still calculating what the middle question is. So we'll move on. In the book Roots, author Alex Haley traced his family history back many generations to the time one of his ancestors was brought to America from Africa. If you could trace your family back 15 generations, starting with your parents, how many ancestors would there be? Let's start with a picture. Here you are, and you have 2 biological parents Mom and dad. And your mom had two biological parents, mom and dad, which to you would be your grandparents. And your dad had a mom and dad, those are your other grandparents. And then your grandma had a mom and dad. Your granddad had a mom and dad. Your mom had a mom and dad. And your grandma, ooh, hopefully your mom isn't also your grandma. Your mom and dad. So starting with your parents, you have 2 ancestors plus 4 grandparents, so we're at 6, plus 8 great-grandparents, so that's 8 plus 6 is 14, so we're at 14. We have to go back how far? We have to go back 15 generations. So it's going to be a really big family tree. But instead of counting them all, we could find a sum. This is a geometric sequence since we're doubling the number of ancestors every generation. So we have to start with 2 parents, we're doubling, and we have 15 generations. So the sum of 15 generations would be 2 times 1 minus 2 to the 15th divided by 1 minus 2. And type that in your calculator and you get this answer. 65,534 ancestors. The next example, I remember hearing this type of example when I was in elementary school, so I'll show you how to answer it. I didn't know how to answer it then, I know now. There's a legend of a king who wanted to reward a boy for a good deed. The king gave the boy a choice. He could have $1 million all at once, or he could be rewarded daily for 30 days with 1 penny on the first day, 2 pennies the second day, and so on, receiving twice as many pennies each day as the previous day. How much would the second option be worth? So he starts with a penny, and he adds double that the next day, and he adds double that, and he adds double that. That's the 4th day, plus the 5th day, plus the 6th day, plus the 7th day. Whoops. So after 1 week, after 7 days, he has $1.27. He's wishing that he chose $1 million. Well, we can see, we want to know the total, so we're finding a sum. We want to know the total, a sub 1, r, and n. Notice it's geometric sequence, and we have an r instead of a d. It's geometric because it's doubling, doubles every day, which is what this is, receiving twice as much. So that's your r, is 2. He starts with 1 penny, 1/100th of a dollar. And this is occurring for 30 days. So you can find the sum after 30 days. Just out of interest, I would wonder how much does he make on the 30th day? Ignore all the other days, 29 other days. Just the 30th day, how much would he make? Just the 30th day. So he would make $5.4 million on the 30th day of lunch. We want to know the whole sum for every day. That would be this, 1 minus 2 to the 30th divided by 1 minus 2. And that number we calculate on our calculator to be $10.7 million. That's a lot of money. On the next one, find a sub 1. We would say 688 is our S sub n. And since we're given a sub n, we'll use the second formula that I showed you. This would be a sub 1 minus a sub n is 16 times -1/2 divided by 1 minus -1/2. So to solve that for a sub 1, you'd multiply both sides by the denominator. That would be 688 times 1.5 equals a sub 1, and that would be plus 8. Subtract 8 from both sides, and you would get this. So you get 1024. Then the next one, notice that you're given n, so we use the other formula, the other one from this one. You'd have 1530 equals a sub 1, 1 minus 2 to the 8th, divided by 1 minus 2, which is -1. Multiply both sides by -1, 1, you get negative 1530 equals a sub 1, 1 minus 2 to the a. Divide by that, and you would get 1530 divided by 1 minus 2 to the a equals a sub 1. And type that into your calculator, and you get the final answer. 6 is the first term. Thank you for watching this video.